So today's lesson 5.7, generating sequences. The objective for today then is to be able to recognise and extend sequences. Prior knowledge before we start, you need to be able to count forwards and backwards, including with negative numbers, fractions and decimals. Things you're going to need: you need your maths book or some paper to write on, a pen or a pencil, and you might want to have a calculator to help you with some of the more tricky questions. Okay, so looking at sequences then. So in maths, we call a list of numbers in an order a sequence. Each number in the sequence is called a term. So here we've got a sequence, hopefully you will recognise it's our 4 times tables or multiples of 4. So 4 is the first term in the sequence. Okay, that's right. And 24 then is the 6th term in the sequence. So we've got our first term, second, third, fourth, fifth, sixth, 7th and 8th. So the term number is simply what position it holds along that sequence. If the terms are next to each other, they're referred to as consecutive terms. So 4 and 8 would be consecutive, 8 and 12 would be consecutive terms. Some sequences you might know already. So some of our sequences have their own names. So this sequence here, hopefully we know, are even numbers. This one might also be called multiples of 2 or the 2 times table as well. This one then are the odd numbers. 3, 6, 9, 12, 15 are our multiples of 3. So again, you might call them 3 times table or multiples of 3. Our 5 times table or multiples of 5. So there are lots of those ones we could have. These ones here then, so do we recognise these? These are our square numbers. We're going to have a look at those a little bit more in a moment. And this set, these are the cube numbers. Another slightly different one, triangle numbers. You might not be as familiar with those. And finally, another group of numbers we should be much more familiar with are our prime numbers. So if you need to, make a note of any of those sequences that you're not sure about. They should be quite recognisable to you if you saw them written down. Now, as well as having them as numbers, we might also have them as a pattern. So here we have a pattern and we can see we've got 1. Here we've got 4 and it makes a square. Here we've got 9 and it makes another square. And these are our square numbers. So this is a pattern of square numbers. So drawn in a pictorial view of those square numbers. We might also do the same with our cube numbers. So we can see we start with 1 cube. To make another cube, remembering a cube, all 3 sides need to be the same size. So 2 by 2 by 2. We would get 8 small cubes to make that. Then 27, 64 and 125. So again, a pictorial representation of our cube numbers. And this one is our triangle numbers, the one you might not be as familiar with. Again, we start with 1. If I want to create a triangle, I need to put 2 more. That creates us a triangle here. To create the next biggest triangle, I would need to add 3 to the bottom to make my triangle. So each time we're adding the next number, we add 4 and we add 5. And that gives us our triangle number. So it makes these triangle patterns as well. So again, a different way of looking at them if you're not sure about those numbers. So today's lesson, we're going to look at number sequences and we're going to look at patterns using pictorial views as well. Okay, so describing and continuing a sequence then. So a sequence here continues by adding 3 each time. So to get from one term to the next term, we simply add 3 and we can keep doing that as long as we want to. So we say that that's the rule for getting from one term to the next is add 3. So when we don't have a special name for a sequence, we can describe it by the rule to get from one number to the next number. We call it the term to term rule. So this rule only helps me to get from one number to the next one along the list. So So the term-to-term rule for this sequence is add 3 or plus 3. Okay, can you work out the next 3 terms in this sequence? So just try for a second to figure out what the next 3 numbers might be. Okay, they're -8, -14 and -20. So how did you work that out? Well, hopefully you've looked at the first number and looked to see the difference between 22 and the 16. And from 22 to 16, we've subtracted 6. From 16 to 10, we've subtracted 6 again. And we've done the same each time. As long as we do the same every time, we have an arithmetic sequence. Okay, and this sequence, the rule would be -6 or subtract 6, whichever way you want to write it. So this is a decreasing sequence. This time it's going down in value, but every time it's going down by exactly the same amount. Okay, so our key points so far then: a sequence is a pattern of numbers or shapes that follow a rule. The numbers in the sequence are called terms. The term-to-term rule describes how we get from one term to the next. Let's see then if we can describe and continue a sequence. So if we're given the first term of a sequence and a rule, we can continue that sequence. So if I were given the first term of 3 and told the rule is to add 4, the first 5 terms would be 3. So our first term we were told was 3. To get the next one, I follow the rule. So I add 4 to my 3 and I get 7. Then I add 4 to my new number. So we're applying the rule to the newest number every time. 11, 15 and 19. That's my first 5 terms. 1, 2, 3, 4 and 5. So as long as we know the first term and what the rule is, we can use that rule, apply it to each new number to get the next number along. So now it's your turn then. Pause the video, have a go at finding the next 5 terms, the first 5 terms in each of the sequences below. So you're told the first term and you're told the rule. So we're going to start with 10, add 3 until we have 5 numbers and then continue with the others. If you need to, you can use your calculator, but try first without, see if you can do it without first. Pause the video, have a go now. All right, so our first one then, so we started with 10, our rule was add 3, so we get 13, 16, 19 and 22. Our next one, we started with 100 and we're subtracting 5 each time, so 95, 90, 85 and 80. Our next one, we're told we're starting with 3 and we're asked to double, so doubling, remember, is multiplying by 2. So 3, then 6, 6 times 2 is 12, times that by 2 we get 24, and times that by 2 we get 48. Remember, we're applying the rule to the last number we wrote down. Our next one then, we're starting with 5 and we're multiplying by 10 each time. So 5, 50, 500, 5,000 and 50,000. And a tricky one now, we're starting with 7 and we're subtracting a quarter. So if I start with 7, I then have 6 3/4, 6 1/2, 6 1/4 and 6. Well done if you managed all of those. All right then, so now we're able to do that. We're going to see if we can work out the next 2 terms. So if I were given the start of a sequence being 0.5, 0.7, 0.9, 1.1, then my next 2 terms will be 1.3 and 1.5. I can see that to go from one number to the next number, we're adding 0.2 each time. So I've worked out the rule and continued the next 2. So again, your turn, pause the video, copy down the first 4 values in our sequence and see if you can write in the next 2 terms. All right, let's talk through these then. So you may have wanted your calculator for a few of these, but hopefully you've given them a good try first. So the first one then, from 4 to 8, we've added 4. From 8 to 12, we've added 4. 12 to 16, we've added 4. So it looks like the rule is to add 4. So we should then get 20 and 24. For the next one, we've got a decreasing sequence. We can see the numbers are getting smaller. So we've had to go from 3.5 down to 2.7. So that's subtracting 0.8. 2.7 to 1.9 is also subtracting 0.8. So we must check it works for each value. So if we continue subtracting 0.8, we get 0.3 and minus 0.5. Another one with fractions then. So we've got minus 2/3 and then we've got minus 1/3. So this is an ascending sequence. The values are getting larger as we go along, and we seem to be adding 1/3 each time. So after 1/3 we get 2/3, and then we get 1 as a whole number. So 3/3, remember, is 1. For D, we've got minus 1.5 minus 2.5, so a descending sequence. So we're taking 1 away each time. So we get minus 4.5 and minus 5.5. And for E, again, a descending, an ascending negative sequence this time. So we've gone from minus 10.6 to minus 9.9 to minus 9.2. So we're moving back towards 0. And so our final two there then, minus 7.8 and minus 7.1. So again, well done if you managed all of those. Those last few are a little bit tricky. Okay, another sequence we should be aware of is the Fibonacci sequence. Now, the Fibonacci sequence was named after an Italian mathematician who used it to describe the growth rates of rabbits. So it's been used by all sorts of different cultures. Fibonacci, the guy it's named after, just happened to be the one to write it down. The traditional then Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, 21, etc. To be able to create the sequence, we need to know the first two values, and we simply add those two together to get the next one and add those on. So as long as we're told 1 and 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, etc. And we can continue that sequence along. Okay, so we now use that name Fibonacci sequence to describe any sequence that follows that same rule. So although this is the traditional one, we can have Fibonacci style sequences which are created by adding the previous two terms to get the next term. So for example, this one here, 3, 3, 6, 9, 15, 24. Well, as long as I'm told 3 and 3, 3 plus 3 is 6, 3 plus 6 is 9, 6 plus 9 is 15, etc. Or we might have this one, 10, 10, or 10 plus 10 is 20, 10 plus 20 is 30, 20 plus 30 is 50, etc. So as long as you know the first two, you can add those together to get the third one and just keep adding the previous two together. So have a go with these, see if you can complete the next 4 terms in these Fibonacci style sequences. Pause the video, have a go now. Okay, so the first one, 5, 5, 10, so 5 plus 5 is 10. So our next number will be 5 plus 10, which is 15, then 25, then 40, then 65. For the next one, we've got 7, then 7, then 14. So we've got to do 7 plus 14, which is 21. Then our 14 plus 21 is 35, then 56 and 91. Now, the last one, threw in a tricky one at the end here. So we started with A, then B. So our next one, remember, we're still adding these two together. So it's A plus B. So now I've got to do B plus A plus B. So that gives us A plus 2B. Now we add those together. So A plus A, that's 2A, and 2B and B is 3B. So again, we're following the same rule, but we're doing it with our A's and our B's. So next we get 3A plus 5B and 5A plus 8B. So we can do this with algebra as well. Okay, moving on then, we're going to have a look now at patterns. So picture sequences are quite common, and we should be able to complete a sequence of pictures and use that to help us to find the rules as well. So it says, first of all, we need to complete the table for the first 3 shapes. So one triangle is made up of 3 matches. We can see that here. 2 triangles, we've got 1, 2, 3, 4, 5 matches. 3 triangles, 1, 2, 3, 4, 5, 6, 7. Okay, We're then asked to draw the next two shapes and update the table. So we can see the shapes have gone by adding extra matches onto the right hand side. So if we add extra matches, our next two patterns will look like that, and we can count up the matchsticks and fill in the table. So we've got 9 and then 11. So now we have enough to hopefully help us to work out a rule and what the next two numbers will be. So we're asked to write in the 6th and 7th, so we don't need to draw them. So let's have a look. From 3 to 5 we've added 2, from 5 to 7 we've added 2, add 2, add 2. So if we continue in that same way, we would get 13 and 15. And to describe how the sequence grows, we added 2 each time. So we need a reasonable amount of values before we can make a prediction about what the next values will be and what rule we're using. It's no good just having 2 or 3 numbers. At least 5 will help us to see that that rule is continuing. Okay, so your turn again now then. So you're asked to draw the next sequence in this pattern. This time we're just going to put the values in the table going in the opposite direction and then describe how the sequence grows. Pause the video, have a go now. Okay, so our next pattern should look like that one. If we complete the table then, pattern number 1 had 5 dots. The next pattern has 1, 2, 3, 4, 5, 6, 7, 8, 9 dots, then 13, then 17, and then 21. Okay, so that we haven't drawn the 5th one, we can see how our pattern is progressing, and our rule is that we've added 4 each time. Okay, finally today then we're going to have a look at a real life problem using our sequences. So Abby and Ben are both saving up for a computer game that costs £40. Abby starts with £20 and saves £4 each week, and Ben starts with £10 and saves £8 each week. Who will be the first to have enough money to buy the game? So again, it helps if you put it into a table. So I've created a little table here of Abby and Ben and the number of weeks. So at the beginning, Abby has got 20. So I've said in week 1, she's got 20 and she saves £4 each week. So I can continue her sequence: 24, 28, 32, 36, and 40. Ben starts with £10 and saves £8 each week. So we've started off with Ben at £10 and he's got £8 each week. Again, up to 40 because he wanted £40. So we can see that Abby, it will take her 6 weeks to get the £40, whereas Ben will take 5 weeks to get £40. So to answer our question, who will be the first? Ben will have the £40 first. Okay, thank you for working through that lesson today. Next lesson, we're going to have a look at how we can predict numbers much further on without having to write out really long sequences.